calculating a confidence interval for proportions. So first things first, this is just going to be the calculations of the confidence interval. We're not really talking so much about the full process today, just specifically how do we calculate it. So you'll hear me say a lot that we're going to assume that conditions for inference are met. So we're cutting out a lot of the steps just to kind of practice on the number part of this process. So a couple things to understand is that to calculate the confidence interval for a proportion, what we have to do is take our statistic, which keeping in mind our statistic is, in our case for this, is p hat. Let me give that thing a little bit of a better hat here, p hat, plus or minus the critical value. Now the critical value for what we'll be dealing with proportions is going to be a z-score, so plus or minus the z-score times the standard error of the statistic. So, I mean, all of this stuff is written right down here. So we have the z-score, we have the statistic, and then we have the standard error of that statistic. Now, what I do want to show you guys is that this all does come from the reference table, and I want to make sure you see how to find it so that way you can access this information whenever you need, because you do not need to memorize this. The only thing you need to know is when we're dealing with confidence intervals for proportions, we need the z-score. Now, when we take a look at our reference table, a couple of things you want to see from our reference table. First thing is when we look at our reference table, we look at that front page here, they do tell you how to find that confidence interval for the statistic. So that information is there. Now for you to identify and fill it in, when you look at the second page, your statistic is the p hat, and your standard error is this guy over here. The only thing you need to know on your own is that the test statistic is a z-score. Now we'll talk about finding like what specifically is that z-score that we're going to be working with next. So first thing, let's take a look at an example question. So the example question that I have for you guys today deals with in 2013, the environmental group Oceana analyzed 1,215 samples of seafood purchased across the United States and genetically compared with the pieces of standard gene fragments that can identify the species. Lab results indicated that 33%, right? So 33% of the seafood was mislabeled according to the U.S. Food and Drug Administration guidelines. We want to assume all conditions for inference are met. What is the 95% confidence interval for the proportion of all seafood food sold in the United States that is mislabeled or misidentified? So again, if we use that formula, right, our confidence interval formula, we need to identify our p hat, add and subtract z critical value times the standard error, and the standard error is p hat times 1 minus p hat, all over n. Now, when we fill in our values, we fill in our numbers. P hat is 0.33. We're going to add and subtract. Now, to find your z-score, this is where our reference tables are going to come into play again. So we're going to go over to our reference tables. And we're going to go over to these reference tables over here. And when we go to our reference tables, we're going to go all the way to the second to last page. The second to last page references the t distribution. Now, when you look at the bottom of this t distribution, you guys will notice confidence levels are right down here, and we're looking for a 95% confidence level. Since we're using z is actually this bottom row that's labeled infinity. So the 95% confidence level, the z-score would be 1.96. So that's what we're going to do. We're going to go back to our equation, and we're going to identify that that z-score is going to have to be that 1.96. So it's going to be 0.33 plus or minus 1.96, and we'll fill in the rest of this. We have our 0.33 times 1 minus 0.33 over that sample size, which I didn't label earlier, is 1,215. All right, so next thing we'll do, at this point, you're just going to type this into your calculator. So we're going to type in 0.33. We have to do the plus and minus separately, so we'll do the minus first. 1.96 times the square root And you guys can use your like alpha y equals buttons to get that fraction, make it a little bit easier for yourselves. 1 minus 0.33 times 0.33 over 1215. And when I do that, when I find the subtraction, I end up with a lower interval of 0.30355. So I'm going to round that to 0.30362. And then you guys could just go up, copy, paste, and just change that minus sign to a plus sign in the calculator. And you guys will end up with 0.3564 as the end of the interval. Now this is your confidence interval. What that means is that we expect at a 95% confidence level that our true proportion of mislabeled seafood, of all seafood in 2013, was mislabeled. The true proportion is going to be between about 30 to about 35%. All right, so that's how we calculate a confidence interval. Now, I do want to just kind of go through one more example with you guys just to make sure, because different confidence levels, different z-scores, things are a little bit different. But our ultimate goal is identify p hat, identify the sample size, and identify that confidence level. So example 2 says, in a poll taken in December 2012, Gallup asked 1,006 U.S. adults whether they were baseball fans. 48% said they were. Assume all conditions of inference are met. We want to find the 99% confidence level to predict the portion of U.S. adults who were baseball fans. So we have a few numbers here. We have our sample size, which is 1,006. We have our p hat, which is the proportion we get from our sample, as 48% or 0.48, and we have a 99% confidence interval that we want to write. So we know this is going to be p hat plus or minus the z-score times the square root of p hat times 1 minus p hat over the sample size. All right, so for our p hat, we already said was the 48%, so we're going to say 0.48 plus or minus. Now our z-score, we're looking for that 99% confidence level. So we're going to take a look at our z-score tables. We're going to look for our 99% confidence, which is this number right here, and look at that first number right above it, so that 2.576. That 2.576 is going to be our z-score. So as we said, that's 2.576, and then we could fill in our standard error. So 0.48 times 1 minus 0.48 over the sample size 1,006. And as we type that confidence interval in, right, we're going to get a different interval. This one right, has a bigger z-score because we're trying to make sure that we're more sure. So we're going to say 0.48 minus, right, I like to do the minus first since this is the lower end of the interval, 2.576 times the square root of 0.48 times 1 minus 0.48. We're going to put that over a sample size of 1,006 US adults. When you guys hit enter, you end up with the low end of our confidence interval is 0.4394. And the upper end will copy paste and just change that minus sign to a plus sign right there at the beginning. So we're adding our margin of error, and we get 0.52057. So I'm going to say 0.5206 as I round it. So my final answer, this would be my final confidence interval, we would say we are 99% sure that the true portion of US adults who like baseball, that are fans of baseball, lies between or is captured on the interval of 0.4394 to 0.5206. All right, so that's how the calculation of confidence intervals works. Let's practice this a little bit and let me know as you guys are working through if you have any trouble.